Hello, welcome to this tutorial in Python. I've only made one video in Python so far and it was terrible. So here we go, let's continue that terribleness. Okay, so we're going to code a binary number converter. So a binary number, if you don't know, looks like this. And I tell you what, the start of this video, I'll just go over the basics of binary numbers and how to work with them. And so if you know all of that, skip ahead to the programming later on. And I might make two videos. So in this video, we'll look at how to go from a binary number like this into a normal decimal number. And in the next video, the second video, then we'll go from how do you go from a decimal number like 123 or 9 or 42, magical 42, how do we go from those numbers and convert it into a list of ones and zeros? I might get to that this video, but it's probably best to split it in two, because at the start of this video, I want to just go over the basics of binary numbers so we understand the algorithms later on. Okay, so this is how binary numbers work. Let's put this number, I don't know, 0, 1, 1. There, we'll finish there. 0, 1, 1. So, the first thing is, in binary digits, this number is not 0, 1, 1. Binary, you read from the right-hand side first. So this number in binary is 1, 1, 0. That's the first thing, and a very important thing. So this is 1, 1, 0. And the second thing is, well, what does that equal in decimal numbers? Decimal numbers are just the ordinary numbers that we're used to. How do we work this out? Well, it depends on the position of each of these digits, and they can be in two states. And those states can be 1 or 0, as you probably worked out. Now, it's like a little switch, I guess, for each of these positions. If that switch is switched on, it will have a 1. If it's switched off, it will have a 0. Good news for a 0, it means you can ignore that number, it's worth nothing. If this position is switched on, if it's got a 1, then you have to add up what that position is valued at. And you just add on all the switches that are on to get your final number. Okay, so think of these three digits. So there are three digits here, 1, 1, and 0. These positions are worth a different value. So each of these three digits are worth a different value. So position gives us the numerical value, if you like, numerical value, or just the value. Okay, so the first position, actually we're in programming, so we start counting from 0. So this is the position 0, this is position 1, and this is position 2. This would be position 3, this is 4, this is 5, this is 6, and so on. Let's just stick with our 1, 1, 0, our three digits. So we've got position 0, position 1, position 2. What we do with those is we take our base number, which is 2, and this is why binary is called binary. That bi means 2, so it can have two states, 0 or 1. We take that and then we raise it to the power of whatever position we've got. So this is position 0, this is position 1, this is position 2. And we add those together. So for position 0, it's switched on. So we're going to do that. 2 to the power 0. The next position 1, is also switched on. So let's add that one. So it's 2 to the power 1. And then position 0, 1, 2. Position 2 is not switched on. So just add nothing, or just leave it at that. Okay, so if you haven't done this in maths yet, what does that mean? 2 to the power 0 or 2 to the power 1? You've probably seen 2 or other numbers to the power 2 before. That means 2 squared, or 2 to the power 3, 2 cubed. And so all you do is take your base number, and then you times it that many times. So for 2 to the power 1, we just do 2 just one time, so it just means 2. If we did 2 to the power 3, it would be not 2 times 3, but 2 times itself 3 times. So 2 times 2 times 2, which will equal 2 times 2 is 4, times 2 is 8. There we go, so that's 2 cubed. 2 to the power 1 is just 2. 2 to the power 0 is quite weird, isn't it? 2 to the power 0, or any number to the power 0, equals 1. Very strange, very strange. But you can kind of see that pattern if we looked at what each of the positions would be. Let's start with 2 to the power 1 is 2. 2 to the power 2 is 4. 2 to the power 3 is 8. 2 to the power, what are we up to, 4 is 16. 2 to the power, we'll stop here because I can't do anymore. It's basically you're doubling n, or the number, each time. So 16 times 2 is 32, and it goes on and on and on. I just heard a baby crying next door or something. Anyway, I thought there's no baby in my house, so I was confused. Okay, so this is 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, and so on. What is 2 to the power 0? Well, you can kind of see how the pattern works if we go backwards. 32 divided by 2 gets us to 16. 16 divided by 2 gets us to 8. Divided by 2 gets us to 4. 2 divided by 2 is 1. So that's where that 1 comes from. So that will happen to any number. Any number to the power 0 equals 1. So we've decoded what any binary number means. You just add, if the digit is switched on, if it's got a 1, the value at that position. So the first position, or position 0, is always worth 1. So if that 1's switched on, it's going to be 1 plus something. And then the next position is worth 2. So that equals 3. So the binary number 110 equals 3. Can you work out how to represent 4 in binary? Maybe you can pause the video and have a little go. I'll have a swig of tea. This is like a maths lesson or something. Okay, well done if you've got the right answer. So to get 4 would be 100, or 100. And remembering we're doing binary, so we should go in the other direction, 001. So let's just see how that works. So the first position is not switched on, so that's 0. Plus next position not switched on, that's just 0. The next position, oh, okay, we've got something switched on. What's that worth? Well, that's going to be 2 to the power. I'm sorry, because I'm writing on a computer, or typing on a computer, I can't write like the 2 with a little 2 at the top, or a little whatever the power is going to be. So sometimes you'll see this little arrow to say, that's where I want the number to be written. Sometimes in programming you can write times, and that means to the power of as well. So you might see that. So anyway, sorry, what position we're at? Position 0, position 1, position 2. So it's 2 to the power of 2, or 2 squared, which equals 4. And that equals 4, of course. There we go. 0 plus 0 plus 4 equals 4. So 001 is 4 in binary. Let's test that out. Up here, let's write 001. And if I press convert, we get 4. Brilliant. So well done. We can do that in reverse, I guess, down the bottom here. Let's write 4, just an ordinary decimal number that we're used to. If I convert that, we should get, yes, 001 in binary. So I've written this little converter. I've called it a 64-bit converter. That means I can write 64 digits. Is that what I mean? I've got confused. Yeah, 64 digits. Or do I just mean I can go up to values of 64? I don't know. I've got confused. But 8 digits would be, 1, 2, 3, 4, 5, 6, 7, 8. There we go. And I believe that's a byte. I believe that's called a byte. So if you've heard of like 2 bytes, it means 2 lots of these. Right. So let's what was I saying? I was saying something about, so I've programmed this in JavaScript. We can go from binary into decimals. So that's what we're going to do. Let's do that in Python. So here I'm in REPL.it. You can code JavaScript, Java, C++, Python, whatever you like, and it's good to be able to program in Python here without using idle or another IDE. It's quite fast, and you can share it and save it quite easily and things like that. This one auto saves, so this is where I'm going to do it. So what we're going to do is, can we, oh, I'm shouting, I've got caps lock on, can we type, first of all, can we convert from a binary array or list? In Python, I don't think you haven't got like a native or a built-in way to deal with arrays, but you can use a list. So I'm going to show you how to do that. So can we convert from a binary array or list, e.g. something like 1, 0, 0, into an ordinary decimal number? Can we do that? That's what we're going to do. So what would be cool actually is if we could input it from the user and then run our little function, our algorithm, and that algorithm returns what the decimal number is and then prints it out to the screen. What might be so we might do that later on. What we'll do at the moment is just build our list here. So let's have a variable called a binary list. And how do you populate a list? It's quite easy. First, if you're dealing with a list, you want square brackets, and that's just like in other programming languages. If you're dealing with an array, so a list of variables contained in like one name, you use square brackets like this. And then what we can do is put those numbers straight in like I've done here. So these will be like integer values, just whole numbers, and we're going to put in 1, 0, 0, although remember that means 0, 0, 1 in binary. We work the other way around. Okay, so we've got a binary list. First step done. So now what we want to do is kind of print out the decimal value equals, and then we want to say some x, some variable. So how do we get hold of x? So we're going to create x as our variable, and that's going to be like the decimal number. So actually, let's call x dec x for some decimal number, some decimal number. You don't have to call it that. You can call it whatever you like, as long as the name isn't already taken by Python. Okay, so our decimal number will equal convert me, and then we're going to put in our bin list. Okay, so we need to write this function. It's going to take in this argument, bin list. So it's going to take in a list, 001, and then it's going to deal with that. It's going to do some magic and spit out the decimal number. So it's going to have to return the decimal number, which will be stored in dec x, and then we're just going to print out decimal equals whatever this variable will hold. Okay, so because we're in Python, I believe we've got to write the function first before we try to call the function. So I don't think we can write the function down here. Let's try that. I'm not very familiar with Python, so maybe I'm wrong. So to write a new function, write def, like for definition, like in mathematics, and then I've called it convert me, and then we're going to take in a parameter which is going to be our list. So I'm just going to bin L, or BL, for binary, some kind of binary list. And I've put a little underscore. You don't have to do that. I just do that to remind me that that's the parameter name for this function, and then colon to say we're going to start the function here, and then press enter, and then in this indent block will be our function body. In other programming languages you might see something like this, and then this will be the function body. Python doesn't work that way. It uses indents to kind of do it neatly, which I don't like. It's scary. I don't like it. It's weird, but there you go. Okay, so at the end of this function, we want to return kind of our decimal. I'm going to call that dec n, decimal number, and we're going to have to work out what the decimal number is based on the binary list that we've inputted. So at the moment, our decimal number is nothing. It's nothing. Okay. So if we think back to when we're experimenting here, when we get a binary number, like 001, convert it, we're converting it by looking at the position. So we're kind of like looping over or iterating over however many positions we've got. This is going to be the length or size of our list, our array. And then at each position, we're just going to say, okay, to find out that number, just do 2 to the power of whatever position you're at. And remember that position goes from 0 to whatever the length of the list is going to be. And how do we get the length of the list? We just do len and then the name of our list. That's the Python function to get the length of a list. We just write len and then in brackets pass in the list itself. Although will that work? Because this is position 0, this is 1, this is 2, and the length will be 3 in this case. So we need to kind of do the length minus 1. Okay, something like that. Okay. Oh, also, if we're looping over our binary list, it's going to start here. It's going to start at position 0, position 1, position 2. So maybe what we want to do first is kind of reverse the list so that we can deal with it in the ordinary way. We can just loop over these positions. So we want to reverse it. So we've got 001. So this will be position 0. This is position 1. This is position 2. Okay. Right. So we've got a basic plan. So it's basically, yeah, we're just teaching the code here to do the process that we did in our head to work out what a binary number means. So firstly, let's reverse it. So to reverse the number, we're going to say our binary list dot reverse. Okay, so that should reverse it. Let's just make sure that's working so far. So let's just say, can I say our decimal number equals binary list? Okay, so we're not returning a decimal number, we're just returning this list back, and now we're going to print out the list. So let's just see if this works so far. And we've got an error. So name convert me is not defined. So the first thing is we've tried to call convert me, this function, and Python doesn't know what that means because so far in our program from here to here it's not been defined. So let's make sure that that call comes after we've defined the function. So as I said before, we've got to write the function out before we can call it in Python. In JavaScript, you have something like called hoisting, I believe, where it doesn't matter where you're going to put your function definitions. They can appear anywhere, and the program will work. JavaScript's like that. It'll just get on with things and kind of work in a messy way. Right, so let's just see if it works yet, or if we've got another bug. We've got another bug. Convert me, this is the same bug, I wasn't expecting that. Line 18, convert me is not defined. Convert me, it is defined, it's right there. So what have I done this time? Name, covert me. Oh, convert me. Right, let's just see. Can we run it this time? No, we can't run it this time. This is the bug I was expecting. Print decimal, so this string here, so that's inside, a string will be inside the quote marks, plus decx. There's a type error. We can only concatenate, that means gluing together, or adding together, plussing together strings. You can only do that if everything you're adding together or concatenating is a string. And decx is not a string, it's got a binary listing. So to convert that into a string is very easy in Python. We just write str and then put that in brackets. There we go. And that'll convert whatever you've got here. If it's an integer, if it's a list in this case, a floating point number, a boolean, true or false, anything, it'll convert it into a string. Okay, so that's quite easy. Can we now run it? Yes, we can. And we've got our list back out. So you can't see that very well. Let's just try to move that. There we go. So we've got 0, 0, 1. Brilliant. Because beforehand we had 1, 0, 0. So our convert me is doing the first thing right. It's reversing the order of our list, and then we're printing out the result at the end. So things are working so far. Okay. So we don't need to do that. Decimal number does not equal the reversed string. What we want to do is now iterate over from the first position in the string. So the first index is going to be 0 to however long that string is, but minus 1. That's quite easy. So we can have a while loop. Let's just say I equals 0. We're going to start at 0. So while I is less than the length or the size of our binary list, loop round and do something. At the end of doing something, I will equal I plus 1. Or we can write that in a cleaner way. I plus equals 1 just means I equals I plus 1. You can see that in other languages. And then in here, we want to say something like if the digit at position I is 1, then what we want to do is, so if it's switched on, if it's a 1 and not a 0, then we want to say something like our decimal number equals the decimal number so far plus whatever whatever 2 raised to the power of 2 is at this position. So we can write this in a cleaner way, just like we've done here with the I. We can just write decimal number plus equals 2 to the power of I. That should be it. Hopefully that makes sense. So this little while loop is just iterating from position 0 to not the whole length. It's going to be while I is less than the length. So it's going to go from 0 to 1 to 2, and then it's going to stop. So it's actually got 3 digits, but it's not going to go to the fourth position. That doesn't exist. And if it's switched on, it's going to add to whatever decimal number is, like a running total, 2 to the power of the position that we're in. So if the first position is switched on, which it is, oh no, sorry, it's reversed. So position 0 is not switched on, it's going to ignore that. Position 1 is 0, it's going to ignore that. Position 2 is switched on, so does equal 1. So it's going to add 2 to the power of position 2, so 2 squared, which equals 4. Okay, then it's going to return decimal number and then print out 4. Hopefully that will work. Okay, let's give that a go. Decimal number equals 4. We've done it. We've done it. We've completed this video. Let's see. What if we switch every decimal number on? What will that equal? Can you work it out? Let's just do it. So it's going to be, let's just do some comments in here. If you want to do comments over lots of lines, by the way, in Python, you can just do 3 quotes, and then anything we write in here, we treat it as a comment, which is quite useful. So let's just work this out. So first position, or position 0 is on, so it's going to be 2 to the power 0, which equals 1. And then we've got 2 to the power 1 equals 2. And then we've got 2 to the power, 2? So 2 squared, which equals 4. So it's 1 plus 2 plus 4. 1 plus 2 plus 4. So 4, 5, 6, 7. Did you get 7? Well done if you've got 7. Let's just see if our program works. Play. Decimal equals 7. Okay, brilliant. It's working. Can we work with 0? Does that work? Yes, it does. Well, that's pretty good. What if we just switch on number 1? Can we get 1? binary number 1 equals 1 in decimal. Very good. What about 2? Remember, in our list, we have to separate those with a comma. Oh, I didn't write it correctly, did I? Sorry, 2 is that way round. 0, 1. That equals 2. Fantastic. What happens if I actually put 10 in? Equals 0, yeah. Because, yes, so the first element, or the first digit, does not equal 1, it equals 10, so it will be ignored. Okay, so remember, for each of your digits in a list, you must separate them with a comma. So, can I remember 42? It was something like 1, 0, 1, 0. Is that right? No, that equals 10. Oh yeah, because the fourth one along, or position 3, will be 8 plus 2, which equals 10. So maybe it was some more. 0, 1. That seems too many now. 42, there we go. I kind of like that, the magical number 42. 0, 1, 0, 1, 0, 1. It's a nice pattern, interesting. Okay, so I hope you enjoyed this first video and it explained how to work with binary numbers. Next video, we're going to try and do what's much more difficult, go the other way around. How can you start with a binary number like this, a decimal number like this, 42, and then convert it into a binary list. Thank you very much. Put in the comments if I've got anything wrong, or you can help me out with any maths or anything like that, or you got any requests about anything else. And thanks for subscribing and everything else. Goodbye. See you in the next video.